Welcome to A A Shah Tutorials. Today we are going to look at class 7 science chapter acids, bases and salts. So what do you understand by acids, bases and salts? Any substance which you have will have some taste, but you can't taste everything. When you taste something and it tastes sour, khatta, when the taste is sour, that substance is an acid. A substance which tastes bitter is a base. But all bitter substances, all substances which are bases, you will not taste them because some substances like detergent powder, soap are also bases. You would not like to taste them, of course. So there are substances which are acids, some are base, and also there are some substances which are neutral. What are we talking about over here is the pH level of the substance. What is pH level? We'll understand that, but we'll first understand what are the substances which you generally see in your day-to-day life which are acids. First and foremost, which you should not even touch, are aerated drinks like Pepsi, Cola, Thumbs Up. All these are having carbonic acid. Their pH level is less than 7. We'll understand what is pH level 2. So, there are carbonic acids, aerated drinks. Then you have acid in your batteries too. This is the car battery also which you look at, which you have in your cars and other vehicles, that has sulfuric acid. Then you have wine, which also has an acid. Wine has tartaric acid. Grapes also have tartaric acid. Grapes is which is used to make wine. So of course, wine also has tartaric acid. Fertilizers which you use are also having acids. That is nitric acid which is present. Nitrogenous fertilizers which you use. So there is acid in them. Then in your stomach, within your stomach also you have acid which is hydrochloric acid. So HCl, hydrochloric acid is the acid present in the stomach. Aspirin, the medicine which you take, aspirin also has an acid, that is salicylic acid. Vinegar has acetic acid. Vinegar is mainly acetic acid combined with water, diluted. Citrus fruits have citric acid as the name suggests, and in labs also, in your chemistry lab, in schools as well, you use acids. So these are various acids which are found in your daily life. Here you can see this is the list which you need to remember. Some standard substances, general commonly used substances and the acids they have. This list is very important. We have already seen few of them. Like we have already seen citrus fruits having citric acid. So you know about them. Then you already know about grapes. As I told you, grapes have tartaric acid. Tamarind is imli. Raw mango. That also has cherry, that also has tartaric acid. So grapes, tamarind and raw mangoes have tartaric acid. Then you have curd which has lactic acid. And sting, the red and bite which you have, which pains, that also is because of the acid which is released by that. And that acid is called formic acid, which is also known as methanoic acid. So these are acids which are generally seen. Vinegar, as we saw already over there too, is acetic acid. Plus amla. Amla and some citrus fruits also have ascorbic acid, which is vitamin C. Ascorbic acid is another name for vitamin C. So these are the acids present generally. Two more which you need to know are about oxalic acid. Oxalic acid is present in vegetables like spinach and tomato, your palak and tomatoes. And onion also have an acid which is called sulfonic acid, which also make you cry. So these are the acids which are present in various substances. Apart from this, the base is present in these 4 common substances and you need to remember them. What are these bases? You can see here. Lime water which is used in chemistry experiments. As you know, a gas which turns lime water milky is carbon dioxide. So carbon dioxide gas turns lime water milky. Lime water has base which is calcium hydroxide. All acids have hydrogen in them, H plus ion in them, and all bases have, acids have H plus ion in them, and all bases have OH minus. OH stands for hydroxide ion. So whenever you see the term hydroxide, means it is a base. So lime water is calcium hydroxide, which is chemically known as CaOH twice. Soap has sodium and potassium hydroxide. Milk of magnesia, which is used in cases of indigestion. When you have indigestion, acidity, you use a base to cancel the effect of the acidity, and that base is milk of magnesia, which is a base having magnesium hydroxide. And window cleaners, detergents, they have a base which is ammonium hydroxide. So these are the common acids and bases. What you need to know basically is that acids are sour in taste and bases are bitter in taste, but you need not taste all of them. Sometimes they are soapy in touch. They are known as bases. So this is a general definition of the term the acids and the bases. Do you have any doubts? Yes, tell me.
So, as we saw that calcium hydroxide, CaOH, 2. So, the 2 is because of the calcium's valency, right?
Of course, correct. Calcium has valency 2. Calcium is 2 plus positive. So, it is a cation. So, anion has, you need 2 anions because OH has 1 negative charge.
But ammonium has OH3. Why is that?
Ammonium hydroxide is NH3. Yes, so ammonia as such has a positive charge and that has 1 negative charge. So ammonia is not an ion, it is a radical. Radical is a group of ions having a charge. Like OH itself is also a radical. O and H together have 1 negative charge. OH minus. So these are acids and bases. Next we come to the next slide, which is about indicators. How do you find whether a substance is an acid or a base? So there are indicators for it. What are the indicators? These are special type of substances which are used to test whether a substance is an acid or base. So these are indicators. There are natural indicators. There are synthetic, means artificial indicators which are created, and there are olfactory indicators also. Can anybody tell me the meaning of the term olfactory? Olfactory is related to?
Chemicals or...
It's nothing related to factory. It is related to smell. Olfactory word is related to smell. So by smell you can come to know whether a substance is an acid or a base. And universal indicator is the most common indicator which will give you a universal idea about whether a substance is acid or a base, as well as how acidic or how basic it is. To understand whether a substance is an acid or a base, you have a pH scale. This is the most important thing in the concept of acids and bases. pH stands for potence, which is a German term which means power. So this is power of hydrogen, because as we saw, acids have H plus ions. So power of hydrogen, and bases have OH minus ions. So we are talking of potential of hydrogen. So it's basically the potential of hydrogen which we see here. So it's a logarithmic scale. What do you mean by logarithmic scale? A linear scale means linearly it will increase. Means if the number is 1, the next number comes 2. But in a logarithmic scale, it will be in terms of power. Means if one number is 10, the next number will 10 power 1, next number is 10 power 2. Means its power increases. Means if this is 10, that next number is 100, next number is 1000. So 10, then 100, then 1000. So it's a logarithmic scale. It's not a linear scale increasing by particular addition of a particular number. Like 1 plus 1 is 2, 2 plus 1 is 3. Or even if you take plus 10, so 1 plus 10 is 1 plus 10, or you say, see, if you start with 0, 0 plus 10, so you will get 10, then 10 plus 10, you will get 20, and so on. So it will be, each number is increasing by plus 10. But in a logarithmic scale, it is a multiple. 10 multiplied by 10, then another multiple of 10. So it increases at a much higher level. Understanding, if you say it's a linear scale, increasing at a linear rate, at the same rate. But at a logarithmic scale, the percentage change is very high. It's 10 times. If it's a scale of 10, it's 10 times. If it's a scale of 2, it's double. Scale of 3 means 3 times. So it's a logarithmic scale, which is used in pH. So, how do you find whether a substance is an acid or base? The scale goes from 0 to 14. 0 to 14. And which is the number in between? 7. And 7 is neutral. So, less than 7 is acid, more than 7 is base. At 7, the substance is neutral. Neutral means no charge. Neither acid nor base. It is neutral. And the most standard example of a neutral substance is water. Pure water, distilled water. If it's a little having pollution, it may be acidic or basic, but pure distilled water will be neutral. At pH level 7, exact 7.
What are only the example of a neutral substance?
Yes. The most common example is water. Other substances made. Then you can create a neutral. You can combine acids and bases and create a neutral solution. It's not that there is nothing else which can be neutral. If you mix them equally, it will become neutral. Both. So pH range is from 0 to 14. 0 means very acidic. 14 means very basic. Another term for basic is alkaline. Alkaline means basic. Okay. pH of neutral solution, as I said, is 7. So it's a concentration of H plus and OH minus ions which you see. So H plus ions, if H plus ions are more, it's acidic. Which is the most acidic substance which you see on this pH scale? Yes, tell me. Yes, battery. The lowest level number which it is most acidic. This is most acidic, acidity is reducing. So lemon next, then you have even stomach, these acids, HCl which is present in the stomach, hydrochloric acid and so on. Right? So acidity keeps on decreasing, milk is very less acidic, 7 we come at neutral, and then it starts becoming alkaline or basic. So blood is a little alkaline, baking soda a little more, and most alkaline substances, drain cleaners. The cleaners which you have, window cleaners, drain cleaners, detergents, all are basic substances. Bleach, everything, soap, correct? All these are bases. Stomach tablets are antacids which we spoke about, to cancel the effect of acidity. Milk of magnesia is most commonly used in case of acidity. So those are basics. Is this clear? So what we are talking about is pH scale. Next we will look at these 4 indicators. How to understand whether a substance is acidic or basic. How to test it. So there are universal indicators as well as natural indicators. Natural means naturally available substances. The 3 most common natural indicators are these. Which are there? Litmus, turmeric and China rose. Even red cabbage leaves are used for that matter too. So litmus paper which you must have seen in your labs. Litmus papers, there are 2 types of litmus papers, red litmus paper and blue litmus paper. They are created. Basically litmus paper is made from lichen. What is a lichen? We'll see all that in detail too. But before that, let's look at universal indicator which is there in front of us first. Universal indicator means what? Universal means it is used for understanding any type of acidity. Means it will give you a clear indication. All other natural indicators will give you whether it is an acid or a base. But a universal indicator will give you the idea of how acidic or how basic a substance is. Basically what it means that depending on the color range, at 7 it will be green. If it's little lighter green on this shade, it is little acidic. Yellowish, little more acidic. Orangish, more acidic. It's going towards red, very acidic. So it's a range of colors which you get if you put universal indicator in a solution. If it's an acidic solution, depending on what is the color, how dark is the color, you will come to know how acidic the substance is. So it gives you the level also, level of acidity, not just giving an idea कि acid है कि base है. Clearly how acidic it is, you can come to know through universal indicator. And what is a universal indicator? It is created by mixing several indicators. So you get a bottle in your labs, you will have universal indicators which is created. So it's a range of colors. Similarly for base also, it goes from light green to dark green to blue till एकदम dark purple. Okay? So depending on the color, you can come to know how acidic or basic a substance is. Right? This is given the whole range of colors for universal indicator. And natural indicators, these 3, they will only give you one color. If the color is this, then it's acid. If the other color is there, then it is base. And what are those colors? First of all, for litmus. Litmus, as I said, is a natural indicator. Means it is not artificial paper created. It's a paper created using litmus which is made from a lichen. What is a lichen?
It is
Symbiotic. Symbiotic means combination. It's a symbiotic association of a fungus and an algae. 2 organisms staying together. And they stay together in the sense that fungus and algae help each other. One is not like, you have leeches or something which is stuck to you and sucking your blood. That is parasitic. A mosquito sucking your blood or something like that, that is parasitic. It is affecting you. You are the main organism. This is an organism which is infesting you, affecting you. Similarly for plants also. No? So that is not symbiotic. Symbiotic means both are useful to each other, both benefit each other. So lichens is a combination of fungus and algae which stay together and help each other in their nutrition. So from that lichen, litmus is made. And what is this litmus? Actually it is purple color. But you see two color litmus papers. One is red, one blue. So red litmus paper, if it is red, if it's turning red means substance is acid. If it is turning blue, this purple color is turning red means acid, blue then it's base. So you create two litmus papers, red litmus paper and blue litmus paper. Acid means which color?
Red.
Red. So you will use red litmus paper or blue litmus paper to test it. To test an acid, which litmus paper should you use?
Red.
It has to turn red, you will use the red litmus paper. You will use the blue litmus paper and if it turns red, it's an acid. For testing a base, you will use red litmus paper. If it turns blue, then it is a base. If you use blue litmus paper, what will turn blue? It's already blue. Understanding? So red means if it's turning red means it's an acid. If it's turning blue, it's a base. Okay? So this is first natural indicator, litmus, which is made from lichens. Second natural indicator is turmeric, haldi. Haldi is used, it's actually yellow in color. You must have seen, if you go to a wedding, you eat something, you stain your clothes and it becomes yellowish. Then you wash it with detergent and what color does it turn into? It turns white.
Red.
It becomes red. What is that red? Because detergents are acidic or basic?
Acidic.
Detergents are acidic.
Basic.
Window cleaner, bleach was on that side of the pH scale. They are all basic. So all these substances are basic. They turn, turmeric will turn reddish orange in them. Reddish orange in them. So turmeric becomes reddish orange in bases and it remains yellow in acids. In case of acids, its color does not change. In case of base, it becomes reddish orange. If you use some detergent, some special solution which will remove the stain is another matter. But normal detergents will make it reddish orange. Okay? So that is turmeric. Third is China rose. China rose is this flower. China rose petals are used to make a solution which is an indicator which will be a pinkish solution. So this China rose petals are dissolved and made into a solution. This is an indicator. So in this pink solution, if you add acid into this solution, it will turn pink. So acids turn pink and base turn green. So this is also a natural indicator. So these are the three natural indicators which we have seen on this screen. Do you understand it? You have to memorize and remember what color change it is to understand when you are doing a test. And this is the table which gives you the gist of everything. Red litmus, blue litmus, turmeric, China rose, and these are the two artificial synthetic indicators which we are seeing right here right now. So two synthetic indicators means artificial indicators which are most commonly used in labs are phenolphthalein and methyl orange. And what is phenolphthalein? It is a colorless solution. So it is colorless and when it is added to acid, it remains colorless. But when it is added to base, it starts turning into pink color. So that is phenolphthalein, pink, and more you add it, it will become reddish pink, darker pink. Right? So this is phenolphthalein and methyl orange. Methyl orange is another indicator which will, it is yellow in color. Though the name is orange, but it is yellow in color and it will remain yellow in base. But in acid it will turn orange. This is the only strange one, methyl orange, which turns red in case of acid, and here phenolphthalein is actually turning pink in bases. Otherwise pink color is generally China rose turns pink in acid, but phenolphthalein turns pink in base. So you will have to memorize this table. Who is able to recollect what have we done so far? Let's see. For red litmus will change its color to blue if it's an acid. If it's an acid, red litmus will be used to test an acid or a base.
Acid. Base.
Red litmus will be used to test a base and the base will turn
Blue.
Blue litmus is used to turn
Red.
used to test acid which will turn red. Turmeric is used to test. Turmeric can be used to test acid or base. Base, because acid it will not change. Base, detergent, base. In base it will turn red. Acid का कोई असर नहीं. Acid will stay yellow only. China rose will give you an idea of both. Magenta Dark pink means acid, green means base. So this China rose helps you in both. These three don't help you in everything. China rose helps you in both. Green means base, magenta means acid. Phenolphthalein will help you test only base. It will turn pink in base. And methyl orange, it will only help you in test acid. It will turn red in acid. So only China rose helps you. Plus universal indicator of course gives you a complete idea. Right? And then the last one is olfactory indicators. What are olfactory indicators? Which change by smell. So the smell changes. If the smell changes, you come to know whether it is an acid or base. Like onion. Onion has acid. We saw in the beginning. Sulfuric acid is what is there in onion. So when it loses its smell, it's a base. If it's added to a base, it loses its smell. So acid का effect neutralize हो जाता है. It is cancelled out. Vanilla, in acid it remains the same. They lose their smell. All of them lose their smell in case of base. So these are olfactory indicators. So if the base is there, it will change its smell. Then with respect to acid, there is acid rain. What is acid rain? What is acid rain? It is greenhouse gases like sulfur dioxide. Greenhouse gases like sulfur dioxide and nitrogen dioxide. There is also carbon dioxide which is present in air. Carbon dioxide when mixed with water will form what? Do you know? CO2 plus H2O. Will give you what?
Acid rain.
No. What will it form? CO2 plus H2O. Which acid or what will it form? Carbonic acid, which is H2CO3. Carbonic acid. But this carbon dioxide is present in air and carbonic acid is always formed, and whenever rain comes, there will be little carbonic acid in the rain. So this carbonic acid is not what causes acid rain. The two other gases which cause acid rain are sulfur dioxide and nitrogen dioxide. These two gases cause acid rain. And what are they? When they react with water, they become sulfuric acid and nitric acid. These are the reactions. Sulfur dioxide first becomes sulfur trioxide, and when added to water, combined with water, it becomes, when it mixes with rain, if sulfur dioxide is present in the air as a pollutant, and it mixes with water, when the rain falls, it will form sulfuric acid, and sulfuric acid is falling down. Of course, it is diluted because it's mixed with water, but it's an acid rain. And nitrogen dioxide also mixed with water forms nitric acid, HNO3. So when these acid rains occur, when there is lot of pollution in the environment, when sulfur dioxide, nitrogen dioxide, these are the gases which are released by vehicle pollutants also, factories. So when they are present in the environment, and when rain falls, it will be acid rain, and acid rain causes harm to buildings, monuments, plants as well as animals. Of course, acid is harmful, and human beings also. So it's here you can see the Taj Mahal. What difference can you see in the two sides of the image?
Color.
This is whitish and this is yellowish in color. So Taj Mahal is made of which stone? Marble. The Taj Mahal is made of marble, and marble, because of the action of the acid, has turned yellowish. So this is the effect of acid rain because of pollution that are historical monuments. Among the wonders of the world is changing its color. It's acid, no? It's acid falling on them. So of course it will affect. If you put, of course plant, but also if there is acid in the water, in rainwater, it's for draining into the rivers. Acid is there. If it's acid rain, then it will result in fishes, aquatic animals being affected. Sit down. Humans are also affected.
So, have there been any recent death because of acid rain?
Not because see, it is diluted. It's not a like acid. If acid falls on you, it will cause you a major injury and a burn. It can burn your skin also if it's in concentrated form. But this is mixed with water, so it will not have immediate effect, but long-term consequences will be visible. Next, the last topic is neutralization. What do you mean by neutralization? Yes, tell me.
The chemical is equally balanced.
Means acids and bases, when they balance each other, they cancel the effect of each other and it becomes neutral. So that is called neutralization. So reaction between an acid and base is neutralization. Two important things which you need to remember regarding neutralization is, one, it will form a salt. Neutralization reaction will form salt and water. Number one, always acid plus base will give you salt plus water. This is standard. Acid plus base means salt plus water. And second thing is, it is an exothermic reaction. Exothermic means it will release heat. Means it will become hot. After the reaction, the test tube will become hot. So acid plus base will form salt plus water, like HCl, hydrochloric acid, plus sodium hydroxide will form NaCl, common salt, and water. So always acid plus base will give you salt and water. Always. Neutralization reaction will always give you salt and water. And second thing, important thing which you should know is that it is an exothermic reaction. It will release heat. It will give out heat. So these are two important things about neutralization reaction. Decomposition or degradation of the food, and it results in tooth decay. So when you use toothpaste, they should be acidic or basic?
Basic.
So they cancel the effect of the acid in the mouth. Soil treatment, again chemical fertilizers have acids. So to neutralize the effect, what should you do? Chemical fertilizers have acids. So to neutralize the effect, what should you do? You should add base to it. And what is the base added? Quicklime. Quicklime is the base added. Quicklime and slaked lime, which are added to acidic soil to neutralize the effect. Otherwise, plants cannot grow. Organic matter also release acid in the soil. So that is also that the basic soil. You can use organic matter, compost, and it will become neutralized. Ant bite, we already saw. Ant bite is also due to the ant bites. It results in release of this acid, formic acid or methanoic acid, which can be neutralized with the help of. So whenever there is an ant bite, what should you apply to the ant bite and it's hurting you? What should you apply? It's an acid. So what should you apply? What should you apply? Baking soda. Baking soda is acidic or basic?
It's acidic.
Baking soda is acid.
Basic.
Baking soda is basic. Sodium bicarbonate, which will result in formation of a base. Sodium hydroxide, when it's mixed with water, so sodium hydroxide will be formed, which will moist baking soda. So when it's reaction to water, it forms hydroxide and will cancel the effect of the acid.
Can vinegar be?
Vinegar is an acid. Vinegar is acetic acid.
But I read about that for wasp bite.
That is different. This is ant bite, formic
So
acid.
ant bite means they inject different acids.
Of course. They inject different components. Na?
Paints a lot.
Correct. Because of this acid, which it releases into us. And lastly is factory waste. As we saw, factory waste also has acids. If acids, they don't treat the waste and drain it into the ocean water bodies, rivers, oceans, then it will result in death of aquatic animals. So for that, factory waste first should be treated with a base, so that the effect of acids is neutralized, and after that, if it is drained out, it will not be so harmful. So that is about neutralization reaction, and with this we end this topic, acids, base and salts. After this you will have 3 tests. One, a basic level test which you will give, we will discuss the answers, then a little higher level, and when you go for Olympiad level preparation, the questions are at much higher level. So to go to that level, first you should gain confidence with simple questions, and then you can gain confidence in answering complicated questions. So we'll see all types of questions. We'll see 3 gradations: basic, intermediate and advanced level questions, so that you are prepared with this topic for Olympiad. So that is for today. Thank you.